show by the principle of mathematical induction that for all n belonging to the set of natural number, the expression 5 raised to the power of 2n plus 2 minus 24n minus 25 is divisible by 576. Okay, let us begin. So here in this particular problem, we are not being asked to prove that this expression is divisible by 576. We need to show here that this statement is true for all natural numbers. That means what we'll do here is we are going to consider a statement Pn, and we are going to suppose that Pn is representing the statement. So we're going to label this as statement number 1. Now, in order to verify that this particular statement is true for all natural numbers, we'll begin by first considering n equals to 1. So for n equals to 1, the statement P of 1 will now become 5 raised to the power of 2 times 1 added to 2 minus 24 times 1 minus 25. So this is going to give us 5 raised to the power of 4 minus 24 minus 25, and 5 raised to the power of 4, that's 625 minus 24 minus 25, that's 49. So this is going to be equals to 576, and this is indeed divisible by 576, which tells us that the statement P of n, this is true. This is true for n equals to 1. So that means if we choose the first natural number 1, then the statement Pn comes out to be true. But we'll have to show that it's true for all other natural numbers as well. So here we're going to make an assumption. We'll suppose that let P of m be true. We're considering a statement P of m, and we're supposing that that statement is true. Now what is the statement P of m? So here P of m is the statement that 5 raised to the power of 2 times. So all we have to do is replace this n with m. So 2 times m plus 2 minus 24m minus 25. So this is divisible by 576. Fine. So we are going to call it statement number 2. Fine. Now, supposing that this particular statement is true, we'll have to show that P of m plus 1, where m plus 1 is the next consecutive natural number to that of m. So this is also true. So this is what we need to show. And what is P of m plus 1? The P of m plus 1 is the statement that is 5 raised to the power of 2 times. So we're going to replace m with m plus 1. 2 times m plus 1 added to 2 minus 24m m plus 1 minus 25 is divisible by 576. So this is what we need to verify. Now, in order to prove that this particular statement is a true statement, we'll take the help of statement number 2. So from statement number 2, we have already assumed that this expression 5 raised to the power of 2m plus 2 minus 24 times m minus 25, that is divisible by 576. That means we can express it as a multiple of 576. So we have 576 times lambda, where lambda is a natural number. Fine, we're going to use that. Now coming to the statement of P of m plus 1. So now we will consider 5 raised to the power of 2 times m plus 1 added to 2 minus 24 times m plus 1 minus 25. So let's try to simplify this expression. So here we have 5 raised to the power of 2m plus 2 added to 2 minus 24 times m minus 24 minus 25. Fine. Then we have 5 raised to the power of 2 times m plus 2. So here we're going to use the law of exponents, and this is going to get multiplied to 5 squared minus 24m minus 24 minus 25. So we have 5 raised to the power of 2m plus 2. So what we can do here is we can use this equation And we can replace 5 raised to the power of 2m plus 2 with 24m added to 25 plus 576 lambda. This will get multiplied to 5 squared, which is 25, minus 24 times m, minus, so negative 24 and negative 25 makes it negative 49. Okay. Furthermore, we have the 24m times 25, so that's going to be, let's keep it as 24 times 25m added to, so 25 multiplied to 25, that's 625 added to, we have 25 multiplied to 576 lambda minus 24 times m minus 49. Okay, now we have 24 times 25m added to, we'll take this, we have 24 times 576 lambda. Next we have 625 minus 49, so that's going to be 576. One more term, so that's negative 24m. Now we're going to combine the first term and the last term, so here we can take 24m as the common factor, so that gets multiplied to, so 25 minus 1 added to 25 times 576 times lambda added to 576. Now we have 24m multiplied to 25 minus 1, that's 24, but 24 times 24, that's 576. So we're 576 times m added to 25 times 576 lambda added to 576. Now we have 3 terms, and each of the 3 terms have 576 as the common factor, so we can pull that out. So 576 gets multiplied to m plus 25 plus 1. Now we have already considered m to be a natural number. Oh, here we have lambda as well. Lambda is also a natural number, which means that m plus 25 lambda plus 1, this is going to be a natural number, which we can replace it with another natural number, beta. So where we have supposed that m plus 25 lambda plus 1, that's equals to beta, which belongs to the set of natural number. So what we have shown here is that we started out by considering 5 raised to the power of 2m plus 1 plus 2 minus 24 times m plus 1 minus 25, and we were able to show that it's a multiple of 576. Now this simply tells us that p of m plus 1, that statement is true, because in that statement all we have to show was that this particular expression is divisible by 576. We have successfully showed that it is indeed divisible by 576. Now if p of n plus 1 is true, now we can generalize our statement and say that the original statement p of n, this is true regardless of whatever natural number that we choose, is going to be true for all values of n belonging to the set of natural number n. Hence proved.